Open ANSYS Workbench. Click and drag Fluid Flow Fluent into the workspace. Right-click on the geometry and select New Design Modular Geometry. A new Design Modular window was opened. Now change the units into mm. Now go to Concept and select 3D Curve. Next, open any browser and search for airfoiltools.com. Select Airfoil Plotter and select any airfoil into it. Click on Plot. You will get the airfoil plotted. Download the coordinate file CSV and open it on Excel sheet. Now copy the X and Y coordinates alone in this Excel sheet and paste it on the new Excel sheet by leaving first two columns. Then enter 0 for the last column E. Then enter 1 for the first column A. Then enter 1, 2, 3 and format it to number of points in column B. Ensure the last number in column B should be 0. After then save the Excel sheet file as text tab delimited file format in your required path. Next, get back to ANSYS Design Modular Geometry. Click on Coordinate File Path and upload the text file which you already saved. Click on Generate. The airfoil geometry is now generated as curve. Now click on XY plane and select Sketch. In sketching, select Rectangle and draw the rectangle in the work plane. Give the dimensions of rectangle H1 as 1500 mm and V2 as 1000 mm. Also, select horizontal in the dimensions and select upstream line and vertical plane, and the distance H3 is given as 500 mm. Similarly, select vertical in the dimensions and select far streamline and horizontal plane and give the distance V6 as 500 mm. Next, go to Concept and select Surface from Sketches. Select the sketch one and click Apply. Click Generate. Next, go to Concept and select Surface from Edges. Select the airfoil curve and click Apply. Click Generate. Go to Create and select Boolean. In that, select Subtract. Select the target body as rectangular surface. Select the tool body as airfoil surface. Click Generate. Now change the surface body as fluid domain and change the solid to fluid. Close this window. Now right-click on Mesh and click Edit. Mesh window was opened and right-click on Mesh and select Method. Geometry selection click and click the fluid domain got selected. Again right-click on Mesh and select Sizing. In Geometry selection click and select the fluid domain surface. Again right-click on Mesh and select Inflation. In that settings, select the geometry as fluid domain surface and select the boundary as airfoil. Change the number of layers to 5 or 10. Now right-click on Mesh and give Generate Mesh. Mesh has been generated. Now select Mesh. And change the element size as 0.05 m. Again right-click and generate mesh. Now select the first edge and right-click and select Name Selection and give the name as Inlet. Now select the second edge downstream and right-click and select Name Selection and give the name as Outlet. Now select the third edge and fourth edge by pressing Ctrl key and right-click and select Name Selection and give the name as Walls. Finally select the airfoil and right-click and select Name Selection and give the name as Airfoil. Now in the project tree name selection boundary conditions are verified by selecting appropriate sections. Now right-click on Mesh and give Update. Next close the Mesh window and select Setup in the workspace and right-click and Edit. Check the double precision and press Start. It took some time to open the Fluent setup completely. After loading a fluid domain model into Fluent Setup, go to Models. Double-click on Viscous Flow and change the K-Omega model to Standard. Double-click on Boundary Conditions. Select Inlet and edit parameters of inlet as 1.5 ms. Check the parameters of other boundary conditions. In reference values, change the area as 1000 times 10 to the power of -6 because the exact area we need to give only after the view of airfoil geometry.
Now double-click on Report Selection. Click New and go to Force Report Lift. Select Wall Fluid Domain. Type CL in the name. Check per zone, Report File, Report Plot, and Print to Console. Click OK. Again, select the Force Report Drag and do the same step which is followed for Lift. Again, select the Force Report Moment and do the same step which is followed for Drag. Double-click on Residual Monitors and change the convergence values of absolute value to order of 1 times 10 to the power of -6. Double-click on Initialization and select Hybrid Initialize. Double-click on Calculation Activities and select one for autosave every iterations. Give number of iterations to 500 and click on Calculate. Now the solver is running. After getting solutions, close this setup window. Now save the file. Right-click on Results. And click on Edit. In post-processing, select Contours and select Locations as Symmetry 1 and click on Apply to see the pressure contours. Similarly, you can select the variable as Velocity and also plot velocity distribution. Click on Streamlines. Select Start From as Inlet. Select Direction as Forward and Backward. Press Apply. You can also increase the number of points into 250 to visualize the streamline effect. We are now going to run for different angle of attack. For that, again go to Geometry and delete Boolean operation. Go to Create and select Body Transformation Rotate in it. Select the airfoil model to rotate for different angle of attack. Select the axis selection as XY plane. Select the axis selection as XY plane. Set the angle as 2 degrees. Now click on the checkbox and rename the input parameter as AOA. Again, go to Create and select Boolean and repeat the procedure which is done earlier. Close the Design Modular geometry. In Workspace, right-click on Mesh and select Update. Measure the airfoil area in the Geometry Design Modular. Again, right-click on Setup and select Edit. Check for appropriate boundary conditions. Double-click on CL and check Create Output Parameter. Double-click on CD and check Create Output Parameter. Double-click on CM and check Create Output Parameter. Double-click on Initialization and click Initialize. In Reference Value, give the reference value of airfoil surface area. Again, initialize the solution. Double-click on Run Calculation and give number of iterations as 300. Click on Calculate. Now Solver is running and the solution is converged at simple iterations. Next, close this Solver setup and right-click on Results in the workspace. Update it. Next, double-click on the parameter set. In P1, AOA section, enter the value as 0, 4, 6, 8, 10. Next, check the Retain box. Now select DP0 row and press Shift and drag for DP5. Right-click and select the command Update the selected design points. Now the solutions are running for different parameters. You can also check the values of CL, CD, and CM for different angle of attack. Right-click on any one design point and make it as current selection to visualize the results of the particular design points. Thus, the simulation of airfoil at various angle of attack experiments are done.